Good morning, Algebra 2 scholars. I have a presentation for you today. So get out your notes. We're moving on to 9.2 and we're going to add a little bit more. Now I have put a lot of graphics in this video to try and explain radians in more than one way. So I hope that it makes it clearer rather than less clear, but here we go. 9.2, as you can see, has to do with angles and radian measure. And you may ask yourself, what the heck is a radian? That's what most of the students I've ever taught has looked for. So really what a radian is a distance of an arc length. So the radian measure of an angle, like any angle on a circle, is the measure of the intercepted arc length. On a unit circle, that's a circle of radius 1. So if you had a circle and you stretched it out, then that part of the circumference that intersects with your central angle is called a radian. Or it's got a measurement in radians. I have a GIF to show you, but in the meantime, this is your conversion. Put this in your notes. Pi radians over 180 degrees is equal to 1. Just remember that. Pi radians over 180 degrees equals 1. So again, here's an example. Let's say I have a roll of toilet paper, and it has a radius of 1. If I took this toilet paper and I started here and I unrolled it so that it was a linear measurement instead, hopefully you can visualize this, then this measurement here is actually the circumference. I just take that yellow line and I stretch it out, and that's the circumference. Well, you know that the circumference is equal to 2 pi r. If we know that r is 1, then the circumference is just 2 pi. So if all the way around your circle is 2 pi, you also know that in degree measurement, that's equal to 360 degrees right there. So if 2 pi is equal to 360, you divide both sides by 2, and what you get is that pi is equal to 180 degrees. So that's where that first conversion comes from. This section is about converting between these two things. So this is sort of like going between feet and yards, or inches and feet, or miles and kilometers. It's a simple conversion. One is an angle measurement, which is the degrees, and the other one is a length, but because it's a curved length, we call it a radian. So here's a great picture. I really like this one. It gives you a picture of exactly what that radian is. And the arc length is the radius. Here is some information on here. If you want to go, I couldn't figure out how to embed this particular GIF, and it's a really great one for you to see exactly what it is. A radian is a unit of measuring angles. Okay, so if you want to take a minute to go to Wikipedia and search for a circle radians GIF, it's really great. I really like it. You can see where if 2 pi is equal to 360, and I want you to do that, so I'm going to give you a second to do that. So this is the picture from that GIF. Hopefully you can see how those are the same, and then pi radians is equal to 180 degrees. And the lengths are the same. So if we then go on to simply review what we already learned in the last video yesterday, remember in standard position, we have a unit circle where we've got 0 degrees, 90 degrees, this is the positive direction, 180, down to 270, and back to 360, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Remember, if I have my ray always starts here at 0, that's my initial side, and wherever I end up drawing that angle, the other ray is the terminal, that's where it ends, and it's showing me that angle measurement. So if we have this unit circle, then we can convert those special triangles from the foldable thing that you made on Friday. And so we can look at all those different angles, not only in degrees, but in radian measures. So this concept summary is in your book, and it's showing you that on a unit circle, like we're studying, say you have 0 degrees, well, that's going to be 0 radians, right? But if you'll look on your foldable thing, I need green. This is your first triangle, the one where you can move it around, and this central angle is 30, and so this triangle right here, okay, is that first special one. That would make the top angle 60 degrees. And so this first section, what we're going to do is practice going between 30 degrees and pi over 6. So say if I have 30 degrees and I want to know what it is in radians, well, I'm going to do this simple conversion. I want to cancel out the degrees, and I want it to be equal to radians. So 180 degrees is equal to pi radians. When you multiply the 30 can be divided by 30, the 180 can be divided by 30, and what you end up with on the top is 1 times pi, and on the bottom it's pi over 6. So that's where these numbers come from, pi over 6. You can take any degree measurement, 210, 240, 330, and use this conversion that we're talking about, and you can change it into radian measures. So the blue numbers on the outside are your radian measures, the red numbers on the inside are your degree measures, and we're going to practice going back and forth between them. It's a simple skill level that we'll do some problems on. Further in your book, it shows you using radian measure. And so one thing I want to point out here, your book's really good at explaining this. Notice 1 radian is approximately equal to 57.3 degrees. So again, this is the same picture. You've got a unit circle of radius 1 radian, and then that arc sector is going to correspond to it, the part of the circumference. So this is the same explanation of what we were talking before. Here's how you go from radians, from degrees to radians. And here's how you go from radians to degrees. Again, it's just a simple conversion. So I've written down a couple of examples here so that we can practice converting them. Your big clue here is if you see degrees, you're going to change this into radians. Like negative 45, you're going to change it into radians. But if you see something with a pi in it, then that means you have radians, and you're going to change it into degrees. You have something with a pi in it, you're going to change it into degrees. Now, normally, if you see a pi, we don't actually write the word radians. That's why I have it here in parentheses. You just have to know that if it's pi, that's radians. Okay, so we're going to go back to 150 degrees. Remember, we want to make the degrees go away. So we're going to multiply by where the degrees are on the bottom. And that's 180 degrees equals pi. Again, you don't have to write the radians. But this is a straightforward multiply by a fraction. Let's see, 150 is divisible by 5, and 180 is divisible by 5. Let's see, or by 30. I can divide that by 30, so let's do that. So 30 into that and 30 into that. So I end up with 5 pi on the top, 6 on the bottom. That's how you convert 150 degrees. The second one, it works exactly the same with negatives. So again, I want to get rid of my negatives, so I'm going to multiply times pi radians over 180. And let's see, 45 goes into 180, so I can divide that by 45, divide that by 45, and I end up with, on the top here, I've got a negative 1 and pi, so it's negative pi over, on the bottom I have a 4, so that's how I get those radians. Okay, exactly the opposite. If I have radians, now I want to convert to degrees, then I'm going to multiply times the degrees has to go on top and the radians have to go on the bottom. The nice thing about that, as you can see, is that my pi's are going to cancel out, which is nice. And then I am going to reduce, let's see, 4 could be divided by 4. 180 can be divided by 4. Okay, so what I'm left with then is 3 times 45 and nothing else. That's 135 degrees. Last example, I have radians. I want to make them go away, so pi goes on the bottom, 180 degrees goes on the top. Let's see. Boy, 7 doesn't, there's nothing divisible here, so I think I'm just going to have to do it straight across. This will be 180 times 10, except my pi's. So 180 times 10 is 1800 over 7. So I'm just going to get an approximate, which is okay, 257.1 degrees. And that's how you convert. So that's what we're going to practice right now. A little bit later in the section, I'll probably do a separate video. We are going to practice finding parts of areas too, and that's called sectors. So, but this is probably enough for now. It's certainly enough to get going on these notes, and then we'll be posting your assignment. You're going to be working in both your student journal and your book. And yeah, I'm going to post it right along with this video. So good luck. We're here for you. Bye for now. Stay safe.